friends, in this video we will discuss about the prestigious Mathematical Olympiad in India. The Mathematical Olympiad in India is organized by Homi Bhabha Center for Science Education on behalf of the National Board for Higher Mathematics. The Olympiad leads the Indian students to participate in the International Mathematical Olympiad IMO. Let us look at the various stages of this Olympiad. The first stage is the Pre RMO. It is a 2.5 hour exam with 30 questions with using an OMR sheet. Around 300 students each from each region or state qualifies Pre RMO and are eligible to appear in RMO. RMO is the second stage. This is a 3 hour descriptive exam with 6 questions. Around 30 students from class 8, 9, 10 and 11 and 6 students from 12 and next 5 girls the from girls quota get selected to the next stage, which is INMO. Before the INMO there is an residential camp for RMO awardees at the regional level. The non-RMO awardees can also attend this camp by paying a fee. You get an opportunity to attend classes by professors from IISc, IIT during this camp. The next stage is INMO exam, and around 900 students all over India attend this exam. This is a 4 hour exam with 6 questions. INMO awardees around 35 nationally gets invited to attend the International Mathematical Olympiad Training Camp or IMOTC. This is a 1 month camp hosted by HBCSC in Mumbai. Last and the final stage is IMO. Based on the performance of IMOTC, the IMO team will be formed representing India. The IMO is a 9 hour exam with 6 questions. The first 3 are given in the first day with 4.5 hours, and the next 3 the next day 4.5 hours. The importance of 6 is that for the first IMO, only 6 countries participated all over the world. That's why they stick on to 6 problems. Now let us look at the eligibility of the Olympiad. Like Indian citizens who are studying class 8, 9, 10 and 11 and 12 are eligible to appear. The syllabus, let's talk about the syllabus. The syllabus of the Olympiad is pre-college mathematics except calculus and statistics. Major subjects are algebra, combinatorics, geometry and number theory. Most of the times 2 questions are asked from geometry itself. Now the exam pattern. Pre RMO exam has 30 questions to be answered in 2.5 hours. The answers are marked in an OMR sheet, either single digit or 2 digit number. For RMO, the RMO subjective questions need to be answered in 3 hours. 6 questions carrying 17 marks each. Partial marks are awarded if you are unable to complete but your approach is correct. You can use any method to solve a problem like geometry or algebraic approach. The cutoff of Pre RMO and RMO are region specific. Normally regions like Mumbai, Delhi, Andhra Pradesh, Bengal and Karnataka will have high cutoff because the performance of the students in that region. For INMO, the pattern is same of that of RMO, but you will get 4 hours to solve 6 questions. And the complexity of the problems will be much higher than RMO, of course. And for IMO is conducted in 2 days. The first day you'll get 3 questions and to be answered in 4.5 hours, and the next day you'll get another 3 questions in 4.5 hours. So it is a 9 hour exam for 6 questions. How to enroll? So to enroll, kindly check with your school maths teacher whether your school is a registered center for RMO. If yes, you can enroll at your school itself. Otherwise, download the student's registration form from the site www.mtaexam.com. This form has to be filled and get endorsed by your school principal, then find the registered centers more near your location from the same site. Submit the completed form to the registered with the exam fee of rupees 230. They will send you a hall ticket to your mail ID. For RMO INMO, you need to register at the HBCSC website www.hbcsc.tifr.res.in. Your RMO and INMO results will also be published in the site. You can also apply for re-evaluation through the site. Now, reference materials. For Pre RMO, I would suggest you to refer the previous year question papers. And for RMO, you can buy a book called An Excursion in Mathematics by Modak. This book is an excellent source of quality problems ideal for RMO. It has previous year questions also, like question papers behind it. It is difficult to get this book in an online or a bookstore, so you may need to contact the publisher Bhaskacharya Publishers, Pune, and buy the book. And I do think this book is sufficient till RMO. Once you clear RMO and attend the INMO camp, you will get some fair ideas of other books needed for the next stage. Scholarship and benefits of the Olympiads. Historically, all IMO awardees have performed extremely well in academics, and most of them are toppers in entrance exams like JEE. Now we will discuss one problem that appeared in 2019. The problem is, let A1, B1, C1, D1, E1 be a regular pentagon for 2 less than or equal to n less than or equal to 11. Let n, b, and d, and en be the pentagon whose vertices are the midpoints of the sides of the pentagon a n minus 1, b n minus 1, c n minus 1, d n minus 1, e n minus 1. All the 5 vertices of each of the 11 pentagons are arbitrarily colored red or blue. Prove that 4 points among these 55 points have the same color and form the vertices of a cyclic quadrilateral. Okay, so in the question we have a pentagon. So this is my regular pentagon, and we take the midpoints of this pentagon, so the sides of this pentagon, and we draw another pentagon. So this is my second pentagon. Okay, then we take the midpoints of this pentagon, and midpoints means the midpoint of the sides, and we draw another pentagon. So this is my third pentagon, and like this we draw, or we have 11 pentagons, and each vertices is colored red or it is colored blue here. So we need to prove that in whichever way we color, we can always find 4 points or that form a cyclic quadrilateral with all the corners the same. So let me draw a pentagon and tell you something. So for any pentagon, if we color the sides with 2 colors, we will have 2 colors adjacent to each other. That is, we have one side with both the points of the same color. So let me try to prove it to you using contradiction, or let's take that corner PA. A, and this is B, this is C, this is D, this is E, and I color A with red. So if I color B with red, then I'm done, right? I will get AB as one of the side, and if I color E with red, I will get AE as one of the side, right? So because of that, I can only color C or D with red color. Okay, so let me color B with blue and E with blue for now, and because they cannot be colored red, Now let's color C with red. C or D doesn't really matter. Now D is the only point which is not colored here, and if I color D with red, I will get CD as my line, and if I color D with blue, I will get ED as my line. So any way we color, we will always have one side which has 2 points of the same color. So I am going to categorize these 11 pentagons into two categories. One is red and one is blue. And the red category is the pentagons having a red side, and the blue are the pentagons having the blue side. Now, in the worst distribution possible, I can have 5 reds and 5 blues, and 1 is left out because we have 11, right? So, this one can go to either the red or the blue. So, this is actually called the pigeonhole principle. I am applying the pigeonhole principle here. So, this one will can go to the red or the blue. So, either the red or the blue will have minimum 6. So, let's say it goes to the red and we have 6 in the red category, and this is called the pigeonhole principle. So this is the pigeonhole principle. So let me only look at the red category now because it has 6, right? If blue was 6, I would look at the blue category. So let's ignore the blue ones for now and look at only the 6. Now if I look at the pentagon, a pentagon has 5 sides, right? So let me name them 1, 2, 3, 4, 5. These are my 5 sides. Now if I go back to my previous diagram, so I'm taking this side, the yellow side, and in my second pentagon, you look carefully, then you can see one side which is parallel to the yellow side, and that is this side. And in my third pentagon also, I have a side which is parallel to the yellow side. So like this, we see that in every pentagon I have one side which is parallel to the rest of the sides of the pentagon of the other pentagons, right? So I can categorize these different sides into 5, right? There are 5 families of parallel lines, right? So let this be 1, 2, 3, 4, 5. So in the worst possible distribution, I am again applying the pigeonhole principle here. So I will have what, 1 1 1 1 1, right? So uh, let's see, we have 1 1 1 1. But look at my red category. I have 6, right? I have 6 pentagons. So one pentagon is left out, and that one pentagon can go to any of the 5. And which let's take side 1. It can go to any. So side 1 has 2. So like this, you can say that minimum one, at least one of the sides or one of the categories have 2, right? Because this is the worst possible distribution. So what I'm left with are 2 parallel lines, and each end or vertex is red color. And by symmetry, I can say that this is actually an isosceles trapezium, right? Because it's symmetric, it's a regular pentagon. So this is an isosceles trapezium, and all isosceles trapeziums are cyclic. Let me show you. If this is theta, then that's theta, that's 180 minus theta. Let me name, this is A, this is B, this is C, this is D. And if I look at here, angle A plus angle C. Wait, my angle C is 180 minus theta, right? So my angle C is 180 minus theta. So angle A plus angle C is actually 180 degrees, which means our quadrilateral ABCD is cyclic. ABCD is cyclic, and just like that, we found a cyclic quadrilateral in our pentagons. That's it. If you have any queries or questions on the subject, kindly write them in the comment section below. I will try to discuss the relevant ones in my next video. Also, welcome any suggestions on this video. Signing off, Madhu CS. Bye.